Hey guys, welcome back to Learn Python the Hard Way. In this exercise we're going to focus on designing and debugging, and we're going to learn specific rules for working with if statements, for loops and while loops, and how we can optimally approach those. So in the previous exercises we already worked with if statements, for loops and while loops, and now let's take a look at some of the best practices. And as always, you'll find the link to the current chapter in the description below. This is part of the paid section of the book, so you would need to purchase the book, or alternatively, of course, feel free to just follow along with the video. So when working with if statements, there are a couple of rules that we should keep in mind. First of all, every if statement must have an else if we actually want to have another branch that we work with. So we can't just write if the statement and then elif and skip the else, so we always have to include that as well. So this else statement should never run because it doesn't make sense. If that's the case, then we should use a die function as we did in the previous exercise that prints out an error message and dies, which is just what we did, and this can help us to find a lot of errors. We should never nest if statements more than 2 levels deep and always try to do them 1 deep. The reason for that is that we can use, in a lot of cases, an elif statement to cover other cases, so we don't need to necessarily nest if statements within if statements. There may be some cases in which we have to do that, but in most cases it's not necessary, and if we have to do it, then we should make sure that we don't make it deeper than 2 hierarchy levels, basically. Next, we should always make sure to treat if statements like paragraphs, where each if, elif, else grouping is like a set of sentences. So put blank lines before and after. And our Boolean tests in our if statements should be simple. If they're complex, then we should move their calculations into a variable and then assign the variable basically to the if condition here. So if we follow these simple rules, then we will start writing better code than most programmers. And so let's keep that in mind. Next, there are a couple of rules for loops. In general, we learned about 2 different kinds of loops, while loops and for loops. We should use while loops only to loop forever, and that means in very few cases actually. If we are looping a certain number of times, then we would use a for loop. So we would use a for loop much more frequently and a while loop just in special cases if we want to loop forever. And then if, for example, we have a certain condition that should be met, then we break out of it. And that would basically be the only case when we use a while loop. So let's take a look at some tips for debugging. So if we have a program, with a bug in it, how would we resolve that? First of all, we should not use a debugger for now. A debugger is basically like doing a full body scan on a sick person. We don't get any specific useful information, and we find a whole lot of information that doesn't help us in any way. So especially in the beginning, we should make sure that we actually take a look at it ourselves and don't use any external tools like a debugger. So the best way for us right now to debug a program is to use a print statement, a print function, to print out the values of variables at points in the program to see where they go wrong. So if, for example, we take a look at one of the programs we worked through previously, for example, the previous exercise that we worked through, then we could just insert a print statement anywhere in our code where we want to test what the output is, for example, of a variable, and that can be very helpful to take a look at what the value is at that specific point in time within our code. And we should make sure that parts of our code or program work as we work on them. So we should not start out to write a massive file of code with lots of lines of code in it and then try to run it all at once, because there the likelihood is very high that we will actually encounter some kind of error and that we actually made a mistake. So in this case, it makes sense to just start very small, run the code, see if it works, and then if it works, to add on to it. And using these tips and approaches, we can actually take a look at some homework here. So the homework would be to write a game similar to the one that we did in the previous exercise. And the author here recommends a certain approach. So as we do this on a sheet of paper or an index card, we typically should start out to write a list of tasks that we need to accomplish in order to finish our program. This is basically our to-do list that we want to use as a basis. Then we pick the easiest element from our to-do list, from our list of tasks we wrote. And then we don't start writing the code right away, but we write out an English comment in our source file that will guide us actually when we eventually write the code. Then after we wrote out those comments, we should write some of the code under the English comments, quickly run the script to see if that code worked, and then keep working in a cycle of writing some code, running it to test it, and fixing it until it works. And then of course, once we have accomplished that, we can cross it off our task list and then pick the next easiest task and repeat. So that helps us to work in a methodical way and in a consistent manner, and allows us to actually update and write good code. So if we were to apply that to the previous exercise that we took a look at, we would of course start out by, before we write any code, start with a sheet of paper or an index card and write a list of tasks that we want to accomplish. That could, for example, correspond to the different functions that we define. So for example, that we want to define a start function, a det function, and then functions for the different rooms, for instance. Those could be our starting points. And then based on that, we can evaluate what the easiest code would be. So maybe it would be the det function here, which is fairly short. Now we would actually start out by writing some code, just where we later on want to add our code in there and describe what it does. So for example, if we started with the start function here, we could write out, print out instructions, get user choice, and then of course break it down in more detail. And after that, we can then start out defining our function, run our code to make sure that it actually works, and then keep on going and adding additional information to it. So for example, in the beginning, we may start out by defining our start function here and just maybe printing out the first line and then checking if that works. And if it does, we can continue with the next line and so on and so forth until we basically implemented this kind of function. And then we can cross it off and take a look at the next easiest task and work through that until ultimately we finished our program. And provided it works properly, we accomplished our game and implemented it ourselves. So that's the approach we should be taking. So that's it for exercise 36, and see you guys in the next video with exercise 37.